This is a quick introduction video to Docker and Docker CLI. Docker is a tool for managing containers. Containers is kind of like a lightweight virtual machine. They're often used to package just a single application. So you package the application with all the libraries and dependencies it requires to run into something called a container image. This container image can then be distributed through a registry like Docker Hub. And then other people can pull down the container image and spin up the application without installing a bunch of stuff on their host operating system. Containers are created from a base image, and there are various base images for various distributions. When you try to spin one up, it requires that you have Docker installed. Of course, you can download that from website. Here I'm using Docker Desktop. So I got this small icon up here. And if I click it, I open a dashboard kind of thing. But I'm gonna use the CLI for it in this video. To run a container from an existing image, we type in Docker run, and then I for interactive, T for TTY, which that's a whole different story for what that is. Just remember Docker run it. Then RM to remove the container after we exit, just so it automatically cleans up. And then we can type name of the image and a command to execute within the image. I could have gone with bash, but here I'm just gonna use simple shell sh. If you run this first time, you'll see it downloading a bunch of stuff. It takes a while, and then you're dropped in to a prompt like this. And now I'm actually inside the container. So I could try to do cat etc issue to check what version of Ubuntu I'm at. So this is 2004, the latest LTS version of Ubuntu at the time of recording. We can exit out with Ctrl D. We'll try a different image. So another popular that's often used as base image for a lot of other containers is something called Alpine Linux. So we can try to run that just by changing Ubuntu to Alpine, and again with sh as shell. And then if I cat etc issue, we see here I'm on Alpine Linux 3.20. If you want to do a different version of Alpine, you can sort of specify a version like this. Most images are tagged with a version number. So basically the name of the base image and then comma and then the tag, which often contains version. Sometimes we have latest which is simply the latest version of the image. So if I go back and pick a bit older, like 3.17, I can launch it like this, and then we could check the version again, and we can see indeed it's 3.17. So this is a really nice way to test out stuff in various distributions. We'll look at some other stuff we can do with Docker in a moment. So the base images, as I shown before, are often used to build other Docker images with a specific application. So we can use those for instance, they exist base images for various database engines. So we could try and spin one up. If I do Docker run, and then we can give the thing a name with tag name, and then give it a name. Like here, I'm gonna go with MyDB. Then we can pass in a environment variable with tag E. So this is gonna be the key or name of the variable, and then its value is gonna be here, in this case my secret. And then we can expose ports with tag P. And then we give port numbers. So we got port number, I think, within the container, and port number on the host. And then tag D means for detached, so we don't see console output, it will just run the thing in the background. Here's the name of the image, Postgres, and we are gonna use the Alpine version. So this is an image building on the Alpine image I showed before, but adds Postgres on top of that. So now it's running in the background. I can check it out by typing docker ps, and yeah, we can see Postgres. Output looks a bit weird when window is small, so often I have full screen for this. Containers have an ID you can use to refer to it, and you can obviously set a name that you can also use to refer to that particular container. You have multiple containers spun up with the same image at the same time, though you might need a different port mapping between the container ports and the host ports. Right, so let's try and connect to the Docker container. I got a thing called dbbeaver. You can use whatever database management tool that supports Postgres for this. I'm just gonna use dbbeaver since I already have it. So we add a new database connection, and then fill out the settings with the same that was passed to your command line. And then we should be able to connect. We can see you connected, and it says Postgres version. It's running on Alpine. So yeah, that's pretty neat. Fire it up, and now we got access to database engine in a Docker container. We can do all sorts of stuff. So the cool thing about this is that you can spin up databases in various versions without installing anything on your host operating system. So if you jump between projects a lot, then you might have projects might have been made with different database engines and different versions. So this just makes it really easy to jump between without installing a bunch of stuff. You could, I don't know, if you use the JetBrains IDs, you could just connect to it in a similar way. I guess I could show really quick in Writer. If I just open up whatever project, doesn't really matter. Then here over in the side, we see a database tab, and then I can click connect to database. I select Postgres, and password is my secret, was what I typed. Of course, for production use, you should use an actually secure password. We test the connection, it does indeed work, and we can connect to it like this. So this works the same in all JetBrains IDEs. You could also use DataGrip for it, or any other management tool. There's a command line utility for managing Postgres databases called PSQL, and we can execute that within the running container with this command, and that will give us a Postgres shell where we can execute queries or do other management tasks. So we get a shell like this. For instance, I could select the version number, be sure to close everything off with a semicolon, and yeah, this selected the version. The database I have here is empty, but if I've created tables, I could do queries against those. I could also use it to create new users and give permission to users and so on. To exit out, Control D. Say your project is using MySQL, then you can spin up MySQL in a Docker container like this instead of Postgres. Looks like I already got a container with that name. Okay, so we're just gonna name it something else, MySQL DB. Right. Now I also got a Docker container running MySQL. You can stop the containers again by running docker stop, and then either the container ID, or you could do docker stop and then use the container name. Both works equally well. Right, now that they are stopped, they are actually still there, so you could start them up again. If you wanna get completely rid of them, we see if we do docker ps tag a for all, we see that they are still there. If you want to completely get rid of them, we do docker rm and then type the name, either the ID or the name of the container. So SQLDB or MyDB, and then I remove both Docker images or both containers, and we can see now the list is empty. We can also use containers to run our own applications. So here I got a simple sample project with just a single web page. If I clone it and then change into the directory, to build a Docker image, you need a file called Docker file. And if you view the content, this is sort of like a recipe for building a new container image. It starts with the name of the base image, which is this case is Nginx. So Nginx is a HTTP or web server, and it's simply the latest version of that. Then right after the base image, you commonly copy your files from your local folder. So we see there's an index HTML and a Linux PNG. These are found here in the current directory. So they get copied into this path within the container image. Then default HTTP and HTTPS ports are being exposed. And then we start the Nginx daemon, and it will simply serve files from this directory. Right, when we have a Docker file, we can build a container from it with docker build, and then the path to the directory containing the Docker file. So we are already in this directory, therefore I put a dot for the current directory. And we can see it downloads the base image, and then it will build the container, which might take a while. So the container is actually gonna be, or the image is actually gonna be named this, which is pretty difficult to remember. So we could give it a nice, a bit more friendly name. We do that by giving it a tag. So we do tag and then the name of the image, and then we can do a version number as well, and a dot again for the directory containing the Docker file. Oh, I had an I at the end. Does that do anything? Should probably. Yeah, there we go. Right, so this gives us a builds an image with a nice name instead. So the name of the image here on our local machine is called Linux Treat App, and then we have version 1.0. We can spin it up with Docker container run, or we could just do a Docker run. It basically means the same. D for detached, so it will run in the background, and P for the ports that are being exposed. Here we specify a port number, and then we can give it a name. So I'm gonna give the container the name Linux Treat App, and then here is the name of the image. So we see Linux Treat App 2 times. One because the container is gonna be named that, and second because that's the name of our image. Then if I open up a web browser and type http://localhost:80, we see the demo app. It's not very interesting, and I guess a picture is missing. That's not my fault, that's how the app was made. So yeah, that's how we can build our own custom Docker image to run a custom application in it. What you then do is, probably if you want to share it with others, you push the image to Docker Hub, though that requires you to create an account. So here you can also search for lots of other images. For instance, we can find the Postgres image we were using earlier. We see it here, and we can see all the different tags or versions of it that we could run. All these Docker images can take up some hard disk space. So to clean up again, we first need to stop all Docker images. Do that with Docker stop, and then if you are in a bash shell, then you can do this syntax to run a command as an argument, which will basically just output all IDs of all containers. So you're basically stopping all containers. We can see here it stopped 2 containers. And then to actually do cleanup so we don't fill out disk space, we do Docker system prune, and we can also delete volumes. So this will delete everything. So if you had some information stored in the container, it will be gone. And we can see it cleaned up, reclaimed quite a bit. So these containers can, even though each container is fairly small, it can over time grow and fill up a lot of space on your hard drive. So I'd say it's a good idea to at least run system prune like this every once in a while